Now we are going to be doing ordinary differential equation. This is a sharp explanation, especially for exam purpose. I'm going to be brushing through all methods of solving differential equation first and second order only. For first order majorly, the second order is just for with constant coefficients. Do you understand? Now look at it. There are some background things you need to know about differential equation. So I wrote ODE. ODE means ordinary differential equation. Now, any equation containing differential coefficients such as dy ds, whenever you see any equation, whenever you see an equation containing dy ds, the square y over the s square, or dy ds all square, etc. You can have like anything containing that is having something like this. It's called a differential equation. So how do you identify a differential equation? Whenever you see something like this, it is what? A differential equation. Do you understand? So now, followed by now, and I'll give you an example of a differential equation. The y ds minus 5y equals 0 is an example of differential equation. 2 the square y over the s square plus xy plus the y ds all square equal cos x is another example of a differential equation. You can see the square u over the s square plus this, all these three are examples of a differential equation. So whenever you see equation like this, it is what? A differential equation. Now, how do you formulate a differential equation? Formulation of differential equation, there are different ways of formulating it, but let me just give you an instance. Now, if you are given y equals sine s, differentiate the first time. This y prime is you are differentiating the first time. You know, when you differentiate sine, you have cos. If you differentiate sine s, the answer is cos s, right? So when you are now differentiating sine 2s, this 2s, you will do as if it's the sine s that is there, isn't it? Or in summary, differentiate sine 2s, the answer is what? 2 cos 2s. I only want to explain how we got 2 cos 2s when you have sine 2s. This 2s, do as if it's only s that is here. Differentiate sine s, the answer is what? Cos s, but it is not s, it is not s like that, it is 2s. Multiply by what? What do you make s? 2. So the answer is 2 cos 2s. Similar approach to differentiate this one the second time. If you differentiate cos 2s, the answer is minus 2. You know, when you differentiate cos, the answer is minus sine. So 2 cos 2s. If you differentiate it, the answer is minus 4 sine 2x. Do you understand? Differentiate what is inside here. The answer is 2. But there is 2 outside before, so that's why it becomes 4. Differentiate 2s, the answer is 2. 2 times this 2, 4. Differentiate cos, you have minus sine 2s. Do you understand? So that's now, and that's equal to minus 4. Don't forget, sine 2s is the same thing as what? Y. So and I replace it. Minus 4 sine 2s, but sine 2s is y, so minus 4y. So bring the minus y here, you become y prime prime plus 4y equals 0. So I have y prime prime for plus 4y is equal to 0. So that is the next thing we have now. That is and when you bring it, I have formulated or I have generated a differential equation. This is the second order differential equation. Don't worry, you will still get to know what we mean by second order and first order. So another way I can write the square y over the s square plus the 4y equals 0. You get that. Now, classification of differential equation. We have two classifications, ODE and PDE. What is ODE? ODE means ordinary differential equation. Then PDE, partial differential equation. So you have two types, but the one I'm focusing on in this video is ODE, ordinary differential equation. Now look at it. A differential equation involving ordinary derivative. A differential equation involving ordinary derivative or total derivative with respect to a single independent variable is called an ODE. What you should take note most is what? With single independent variable is called what? An ODE. Example of an ODE: the square y over the s square plus 3y dy ds plus y equals 0. Throughout, you see that we only differentiated with respect to x. So in this case, you see y is a function of x, or most f of x comma y equals 0. So my point is, you differentiate with respect to a what? Single variable, and you don't have a partial differentiation anywhere. When the derivative is partial, it's written this way: du, maybe du dx. This one is partial derivative, but if it's total derivative of the ordinary differentiation, you write the u ds. Do you understand? That is that is how to know. So an example of an ordinary differential equation, you see this is an example, this is another example. Now look at this one. A differential equation involving partial derivative of one or more dependent variable dependent variable with respect to more than one independent variable is called a PDE. So one or more dependent variable with respect to what? More than one. This one is very important. More than one independent variable is called a partial differential equation. Example, you can see the v dt plus the v ds. This one is differentiated partially with respect to t, another derivative with respect to x is equal to v squared. This is a partial differential equation. See this one, Laplace equation, or what do we call this one again? So d square u over the x square plus d square u over the y square equals 0. So this is also another partial differential equation. Now we want to define order. What do we call order? The order of the highest order derivative involving in a differential equation is called the derivative of the differential. It calls the order of the differential equation. What is it saying? Let me show you an example before I explain order again. For example, you have the square y over the x squared minus 3 dy dx plus 2y equal 1. See, the highest order, like the highest power of the derivative in quote, like of the number of times you differentiated, the highest one is the order of that differential equation. So the highest power of the derivative of the number of times of differentiation is 2 here. So this is of order 2. Or the highest power here you can see is 4, so it's of order 4. Example again now, the order of a differential equation is the highest order derivative, like the highest order derivative, that is the highest number of differentiation you have done, the highest of them. That is what we call the order. So in reality, you see the square y over the x square plus the y. There is no other one that is up to the square y over the x square again. So this is of order what? 2. This one, the 4y over the x4 minus 6xy equals 0. This is of order what? 4. Do you understand? Now, the highest power to which any of the derivative in a differential equation is raised. So I have defined order. For you to know the order of a derivative of a differential equation, rather, it is the number of times, the highest number of times they differentiated. The highest number of times they differentiated that is appearing in that equation, that is the order of the differential equation. This is of order 2, because that you can't, this is order 1, the y ds, but the highest order 2. This one order 4. So you get my point. That is the answer to this question. Now, the highest power to which any of the derivative in a differential equation is raised is the degree of the equation. There is order, there is degree. I have explained order. Now degree. Look at this example now. The square y over the x square all over the x square plus the y ds. You see, this one is raised to power 3 minus 3s the y ds equal to y. This is of order. This is of degree 3. Do you understand? You will look at the differential equation, the derivative, the differential, the one that have the y ds or the square y over the x square, like the one that have the highest power of them is the degree. So in this case now, the highest number of times they differentiated is 2, the square y over the x square. You see, order 2. That's the order. Do you understand? But you will not. This one is raised to power what? 1. This one is raised to power what? 3. This one is raised to power what? 1. The highest of them is the degree. This is raised to 3, so it's of degree 3. Example 2. This one is d cube y over the x cube. D cube y over the x cube, right? Plus 2 the square y over the x square raised to power 4. Minus 3 dy dx equal cos x is of degree 4. Order 3. You see, the highest number of times they differentiated is 3. So this is what? Order 3. But this is raised to power 1, this is raised to power 4, this is raised to power 1. So it is of degree 4. Now look at the last one. Obviously you will know that this is of degree is of order 3. This is a third order. Order 3. This is raised to power 1, this is raised to power 2, this is raised to power 1, this is raised to power 1. But they say it's of degree 3. How? But they say it's of degree 3. Now note, mind you, this is of degree 2, right? But y is multiplying it. Y, I wrote xy, but I'll circle xy, but y is multiplying it. Whenever y is multiplying any of the differential, like y on its own is also having a power. Well, y is degree 1, like the degree of y is 1 plus the degree of the y ds here is 2. So that makes it 3. So that's why it is of degree 3. So if you have y multiplied by invert, if you have y square multiplied by the y ds raised to power 3, this is degree 5, because this one is having square, this one is having cube. Degree what? 5. If we have the y ds, another one, if we have the y ds and you have the square y over the s square raised to power 6, the degree will be 7, because this one is degree 1 plus 6. 1 plus 6 gives 7. Do you understand? So stay tuned, let me write the remaining properties, then we'll move to solving first order differential equation. We are going to start with first order, how to solve them, different methods of solving first order differential equation for exam purpose. Do you understand? Stay tuned, and remember to please click the subscribe button and share this video. Thank you very much. So now let's continue. So let me quickly summarize the remaining part of the beginning of differential equation. Now, we have defined order and degree of a differential equation. Now, an ordinary differential equation is said to be linear if the differential equation is of degree 1. That means if the degree is more than 1, it is no longer linear again. A differential equation is said to be linear if it is of degree 1. A linear ordinary differential equation of order n is generally given by this. You know the meaning of order now, that is the number of times, the highest number of times they differentiated. Now, this is the n dy. This is how you normally write like the general way of writing a differential equation, like the order, a linear ordinary differential equation. The general way they normally write it of order n is a naught of x, the ny over the xn plus a1 till you get to y equal bx. That is the general way. But then leave that one. We don't need the general way this for first order and second order. This can be just an objective question. Now remark, if an ordinary differential equation is linear, what happened? Then the following condition must hold. So how do you know whether a differential equation is linear or not? Number 1, the dependent variable y and its various derivatives occur to the first degree only. Do you understand? It must be of degree 1. Another way of defining this is that the y, like y itself and the y ds, they must be of order 1, like the power must be 1. They must occur to their first degree. And there is no product of dependent variable y, and so let me first explain this better. It means that y, the y ds, d square y over the s square, and on like that. It means that all these ones, their power is 1. Do you understand? Their power is 1. Now leave that. There is no product of dependent variable and y and dependent variable y and its derivative in the equation. Otherwise, it is non-linear. So if you look at the differential equation and all these ones, they are of power 1. That is first condition. Number 2 condition, there is nothing like y times dy ds or y times maybe the square y over the s square and on like that. y and then y multiplied by the y dx if it's not there, or y square multiplied by the square y over the x square, or any of that, all these things, whether the y dx or y, all these things must not multiply themselves together. If they multiply them, if something like this appear in the equation, it is no more linear. Do you understand? So these two conditions must hold. Now, what do I mean by example? This example I wrote, we want to classify the following differential equation. So if they say you should name this differential equation, what will you call it? Number one is what? This is a second order. Do you get that? You look at the order first. The highest number of times they differentiated. This is a second order, right? Differential equation, ODE. Don't forget, this is not a PDE. This is a second order ordinary differential equation. Ordinary differential equation. So this is a second order ordinary differential equation. Do you understand? Of which degree? Of degree 1. Do you understand? You can say of degree 1, or if I write a linear means it is of degree 1. Well, what's the degree? The degree is 1. Do you understand? The power of this one is 1, the power of this one is 1, the power of this one is 1. So the degree is 1. Do you understand? So a second order ordinary differential equation of degree 1. And what does that mean? Of degree 1, that means it's what? Linear. It is linear. And it is linear. Or another way I write it is a linear second order differential equation. Finish. When you put linear, it is the same thing as writing degree 1. Do you understand? Now, this one, what is the order? Third. And it is also linear because the power of this one is 1, the power of this one is 1, the power of this one is 1. The power, you know what I mean by the power, not the number of times they differentiate. This one is order 3, order 2, order 1. Do you understand? Now, so this differential equation, the answer to this one is what? A linear third order. Third order what? ODE. What is the meaning of ODE? I just shortened it. A linear third order ordinary differential equation. Right? Look at this one now. It's having square. The order is 2. I mean the degree is 2. Because it's having square. The degree is 2, so it is not linear. A non-linear second order. This is second order, the highest number of times they differentiated. A non-linear second order differential equation. A non-linear second order ODE or ordinary differential equation. A non-linear second order ordinary differential equation of what? Degree 2. Then lastly, this one, y is having raised to power what? 3. Don't forget, what's it called? They have told me before that the dependent variable y and their derivative must appear in their first degree for it to be linear. So since I don't have that, it is not linear. So this is what? A non-linear fourth order differential equation, right? Finish of degree 3. Of degree 3. This is the power here is 1, the power here is 1, the power here is 3. Of degree 3. Do you understand? So that's enough of classification. So in case you are asking your objective or maybe your theory, question 5 AI, you should be able to answer them correctly. Now let's come to this one. Now let's come to how to solve the differential equation. Now let's talk about first order. first order differential equation. The general form of a first order differential, you know what we mean by order now. It means that the highest number of times the differentiated is just one, the differentiated one. So I have a naught of x dy dx plus a1 of xy equal bx. Do you understand? Don't mind the noise of the rain. Just pay attention here and let's continue. Now, this is a naught of x dy dx plus a1y equal b of x. It can be written as what? Dy dx. This is the general way of writing it. Do you understand? This is the general way of writing a first order differential equation. You can also write it this way: dy dx equal f of x comma y. In fact, f of x comma y can be m of xy all over n of xy. Whichever way you are writing it, these are the three different ways of writing a first order differential equation. Do you understand? Even there are other ways to write it as well, different ways, but you understand what they mean by a first order differential equation. Now, the first way of solving a first order differential equation, you know, I told you there are different methods of solving a first order differential equation. The first method, variable separable equation. When you have a variable separable, given that dy dx equal f of x comma y, look at it, dy dx equal f of x comma y, and this f of x comma y, you can separate it that you can have in one bracket all the variable x. You can have in another bracket the variable y, that is, you can completely separate x from y. Like x can stand alone, the whole of the function of x can stand alone, the whole of the function of y can stand alone, that is r of x and s of y. Then it is variable separable. And when you have that like that, that means the y dx will become r of x, f of y. So at this junction, you will now cross multiply and let all the y stay in one side, let all the s stay in another side. So look at the y here. The y is here, bring s of y here. You see that? R of s stay in the other side, then the y go there. Integrate both sides. So you will integrate the y over s of y equal integrate r of x ds plus c. Now don't forget, whenever you are done integrating, you must write plus a constant. You have that. Now, work example. Solve the equation. You might be given a differential equation and you are told to solve. Number one thing is, let me tell you something. They will not tell you which method to use. If they are kind enough, they will tell you by variable separable, obtain the solution of this differential equation, or they will just say solve the equation, like solve the differential equation. So the first thing you need to look at is that, is it variable separable? Look at how I'm going to solve this now. Pay attention. Is it variable separable? The first one, I have y tan s dy over ds is equal to what? 25 minus y squared sec square s. Check whether you can bring all the y to one side and take all the s to the other side. If that is possible, then it is variable separable. Look at the way I'm going to do it now. We want to solve this differential equation. So let this 25 minus y come here, or let me show you something. Cross multiply. This is over 1. Cross multiply. You will have what? Y tan x dy is equal to what? 25 minus y squared sec square s ds. That is what you are going to have. Let the y, let all the s stay this side, let the y go there. So these two, 25 minus y squared, bring it here. This one, take it here. So look at what I'm going to do. I will divide both sides. Since this one is coming here, 25 minus y squared. Since this one is going there, tan s. Divide both sides by 25 minus y squared tan s. So 25 minus y squared, we cancel this one. You see it's out. Tan s, we cancel this one. So you see that I'll actually be left with y over 25 minus y squared dy is equal to what? sec square s over tan s ds. So if you look at it now, the whole of everything here is just y, everything here is x. I have separated the variable. That's the meaning, separating the variable. So what is left for me is to integrate. That's what this thing is saying. The y over something equal r of x over something. This is it. So just integrate and you are through. I hope you understand my point here. So that's what is left for me. Integrating both sides. Integrate this integral of y over 25 minus y squared dy is equal to integral of sec square s over tan s ds. Differentiate what is at the denominator. If you differentiate what is at the denominator, what do you have? If you differentiate 25 is 0 minus y squared, the answer is minus 2y. You know, and don't forget, let me tell you, or if you don't know, if you differentiate the denominator and you get the numerator, the answer is ln of the denominator. So, but if I differentiate this denominator, I have minus 2y, right? What will happen? Look at what I'm going to do. I will force my way in. I'll put minus 2 here, then minus 1 over 2 outside. Why? I want it to be such that if I differentiate what is down, I get what is up. So because of that, look at it, minus will give me plus. 2 cancel 2. You see that I have not changed the question. I'll come back to the question. So, but now this one will now be equal to minus 1 over 2 ln of what? 25 minus y squared. Do you understand? If you differentiate it down and you get the up, the answer is ln of the down of the denominator. That's one law of integration. Is equal to differentiate tan s. The answer is sec square s. So that means that this one too, ln of tan s, because when I differentiate tan s, the answer is sec square s. Then plus what? Plus a constant. But see, look at it. Plus a constant. See, you can stop here. That is your answer. You are through. Like once you can remove the y dx and integral, and you can remove integral, you are done differentiating. You can leave your answer like this. But if you want to show stunts, you can still simplify your answer. Like if you want to show stunts, now maybe you want to remove this lane, you can remove the lane actually. So you can still have, assuming I want to, suppose I want to show stunts, I will have minus 1 over 2 ln 25 minus y squared is equal to ln of tan s. Instead of writing plus c, I will write plus ln what? Ln k. So that the three of them will be in terms of what? Ln. So what will happen after that? Since the three of them is in terms of is in ln term, what happens is bring the power, bring this one here. You know, don't forget this is logarithm. Ln of 25 minus y squared raised to power minus 1 over 2. This is actually I'm using the law of logarithm here. Maybe I should show you. Ln is logarithm. Ln is log to base e. Ln is log to base e. Ln. If they say ln x, that's log to base e of x. So it's logarithm. So and don't forget when you have p log a, for instance, this is the same as log a p, a raised to power p. So that's what I've done. This minus 1 over 2 that you see here, I bring it up to become power because it's part of the law of logarithm. And don't forget when you have log m plus log n, this is log what? Mn. Law of logarithm, right? So now, so instead of writing c, I write ln k because it's still a constant. If you have ln, it's still a constant. How do you know it's still? How do I know it's still a constant? I can just say let c be equal to ln k. That's finished. So this is ln tan s plus ln k. This is by that law, second law I wrote. This is ln k tan s. Ln k tan s. Do you understand? Log a plus log b is log ab, or ln k tan s. Now you can now cut the ln of both sides or taking exponential of both sides. Ln cancel what? Ln. You will be left with what? 25 minus y squared raised to power minus 1 over 2 is equal to k tan s. You can stop there again. If you still want to show stuff, you can continue. This is 1 over square root of 25 minus y square equal this. You can do that. Do you understand? The point is, once you get here, you are through. The second one, number 2, B. Now, s sin y dy ds plus x squared plus 1 cos y dy is equal to 0. So now to give me that y1 equal pi over 2. Now, we want to differentiate this. Okay, I'm the one that this is s sin y ds, not dy ds. S sin y ds plus this dy equals 0. Take this one to where the other side. You will be left with s squared plus 1 cos y dy. Bring this one to the other side to become minus s sin y. Yes. Is it possible for you to take all the s to one side and bring all the y to one side? Yes. So since it is possible like that, you will what? You will do that. And that is what we call variable separable. We are separating the variable. So now take s, let it come here, bring y, let it come here. So actually you'll be left with cos s, no, cos here is here already, dy. What is called sin s? All over sin s, sin y. Sin y has come here. Is equal to, this one that's left. Maybe I need to show you. Sin y is already here, so that means it has left. What is left here is what? Minus s ds all over what? This one is going there. S squared plus 1. Do you understand? So I have said everything on the left hand side is in terms of y, everything on the right hand side is in terms of x. So that is what we call variable separable. What is left for me is to integrate. Integrate cos what? Cos y over sin y dy is equal to integral of minus x over s squared plus 1 ds. Right? So if you differentiate what is down, differentiate sin x, you get cos x, but now differentiate sin y, you get cos y. The answer is ln. Ln of sin y. Ln of sin y is equal to, now look at this one. Let the minus come out. It's a constant. Differentiate what is down. Differentiate s squared. The answer is what? 2s. But I have x here. It's very simple. You just put minus. No, minus is there before. Put 1 over 2 outside, put 2. So cancel 2. So differentiate what is down, you have 2s now. So this is minus 1 over 2 ln s squared plus 1, right? Then plus a constant, but the constant, write it as ln k. So again, why you understand why I write it as ln k now? You are used to it now because everything is having ln. So this is ln sin y equal. Now let this minus 1 over 2 come up. So it becomes ln s squared plus 1 raised to power what? Minus 1 over 2 plus ln what? K. So this is ln sin. Don't cut ln and say ln cut. Don't do like that. Oh. Everything has to be one, like to be together before you can say ln cut ln. Ln sin y equal log a plus log b log ab. So ln of open bracket k, then you now have s squared plus 1 raised to power 1 over 2. So ln can now cut ln now. But when you see our plus, minus, any other thing like that, don't go and cut the ln. Everything has to be must be inside the ln before they can cut. So ln cancel ln, you will be left with sin y equal k open bracket s squared plus 1 raised to power minus 1 over 2. Now this is where we are. Don't forget, assuming they are just to integrate, I would have stopped here. I might have stopped here. You understand? Actually, you can even stop here. You just need to, you unlike plus c, you just need to find c don't forget they give you this condition. This condition is given so that you can find C, y of 1 equal pi over 2. What does that mean? Y1 equal pi over 2. What is here is S. It means that S is equal to 1. What is inside? Then Y, that means when S is 1, Y is pi over 2. Do you understand? That is what it means. So put it there. That means this is sine pi over 2. Pi over 2, don't forget pi is 180. 180 divided by 2 is 9. So sine pi over 2 equal k x squared. That's 1. 1 squared is what? 1. 1 plus 1 raised to power minus 1 over 2. So now, let me see whether I can round off it. Sine pi over 2 is what? 1. Sine 90. Sine 90 is 1 equal k, open bracket, 2 raised to the power of minus 1 over 2. Isn't it? So now from law of indices, this is 1 equal k. No, to remove this minus from law of indices, when you have a raised to power minus m, what does that mean? 1 over a raised to power m. You know, when you have indices, a raised to power minus m is 1 over a raised to power m. That's what you do now. So this is 1 over 2 raised to power 1 over 2. So this is 1 equal k times 1 is k over root 2. So cross multiply. That means k will be what? K will be equal to root 2. So you've gotten the constant. So just put in the value now. So we slot in the values. K is equal to root 2. So that means that I have what? Sine y equal k is what? Root 2. Root 2 x squared plus 1 raised to power minus 1 over 2. And that will be the answer. So let's go to homogeneous equation. So let us quickly talk about homogeneous equation. Now, I'm through with variable separable. Now for homogeneous equation, a function f of x is said to be a homogeneous equation if there exists another function f of tx ty such that f of tx comma ty equal t raised to power n f of xy for all x and y. Now n is the degree of the homogeneous function. Do you understand? Now to solve, substitute v equal y over x. Don't worry, all the things I'm saying you will understand. Now look at these two examples again. Verify the homogeneity of the differential equation and solve the differential equation. Now the first one, I have what? X squared plus 3y squared ds. ds is there, so I didn't write this. Plus 3y squared ds plus 2xy dy. Actually, if you are in the examination hall, the first thing for you to do is that you should check whether the differential equation is variable separable. If it's variable separable, use variable separable and solve the differential equation. If it's not variable separable, you will now come and check whether it's homogeneous. Now look at it. The first thing is that if you I have 2xy dy, bring this one to the other side, I have minus x squared plus 3y squared ds. If you look at it, it is not variable separable because you can only divide through by x squared plus 3y squared. So if you divide through by x squared plus 3y squared, like you can't separate all the oy to be on one side and all the os to be on one side. Do you understand? So since it's not variable separable, make the y ds the subject of formula. So if you look at it very well, the y ds, divide this one, like this one will come here, this one will come here. So the y ds is minus x squared plus 3y squared all over 2xy. So this is your f of xy. This is your f of xy. Minus x squared plus 3y squared all over 2xy, as you can see. Now, what am I trying to do here? What I'm trying to do here is that you say a function is said to be homogeneous if f of ts comma ty equal to raised power n equal f of xy. So I have to check whether this is homogeneous. So this is f of xy, the y ds equal this. So this is f of xy. So check f of ts, f of ty. If you check for f of tx and f of ty, what are you going to get? You have f of ts comma ty So anywhere you see s, put ts. Anywhere you see y, put ty. So this is minus ts all square plus 3ty all square all over what? 2s. S is ts, y is what? ty. Now look at it. This is minus, this one will give me what? T square s square plus 3t square y square all over what? 2t square xy. T square is common here, isn't it? If you factorize t square, this is t square, then you'll be left with what? Minus t square. This dot means times t square, then minus you have s square plus 3y square. You know, our t square is common here. If you bring out t square, it remains s square. If you bring out t square, it remains 3y square. So this is the minus. Even at the denominator too, t square can come out like t square. Then you are left with what? 2. You are left with 2xy. 2xy. If you look at this, minus s square plus 3y square all over 2xy. Minus s square plus 3y square all over 2xy. So that means that f of ts ty is actually equal to, so this is the t square. You can cut it, but don't cut it. You know, they are saying t raised to power n f of tx. So the n is 2. So that means the degree of this homogeneous, of this differential equation, like the degree of the homogeneity of this what's it called, of this homogeneous function is 2. Do you understand? You know, I told you that n is the degree of the homogeneous function. So the degree of this homogeneous function is 2. So I can say that it can cut. So because of that, I can say that minus x squared plus 3y squared. No. So I can write this like t squared. If I want to write it this way, t squared, it can cut, but t squared, f of this one is f of x comma y. So you see that the differential equation is homogeneous. Thus, the differential equation is homogeneous. Now you will now solve. Don't forget what you solve. To solve, you will let b to be what? Y over x. So, but then come back to this. So, the first thing I did here is that I have shown that it is an homogeneous equation, right? Now solve it. I'll start from it. This is where you start from. dy ds is equal to minus s squared. Let me even open the bracket. This is minus s squared minus 3y squared all over what? 2xy. You know, you will let, they say let v to be equal to what? Y over x. Isn't it? What is y? So you say let v to be y over s. So what does that mean? Y equal what? Vs. This v is a function of x. Do you understand? So but cross multiply, y equal vx. So that means anywhere you see y, you will put what? Vx, right? So that means this differential equation will actually become, anywhere you see y, put vx. So this is minus s squared, right? Minus what? 3y, which is vs all square all over 2s multiplied by what? Vs. Do you understand? Now so y equal vs. I'll still use this one, but let me first clear this one. I'll still use this. I'll still come back to this. But then pay attention. So the y ds, this one will become minus s squared minus 3v squared s squared all about 2v s squared. If you open the bracket, right? Now you will notice that s squared is common. Factorize the s squared. S squared is common at the numerator, right? So s squared is common. I will have s squared. I will still be left with minus 1. Nothing will be here again. Minus 1 is what will be remaining here. Plus 3v squared. That's what you will have. All over 2v s squared. The square will cancel. I mean the s squared at the numerator will cancel the s squared at the denominator. This cancel this. So you will be left with what? The y ds is equal to minus 1 plus 3v squared all over 2v. Call this one equation 1. Right? Call it equation 1. Now, come to this one now. From y equal y equal vs. Differentiate with respect to s. dy ds. This is product. You use product rule, or you don't use product rule, or see this one v. You first take v, differentiate s squared 1 plus you now take s, differentiate v, that is the v ds. Don't forget I told you v is a function of x. Whenever you differentiate y, you write the y ds because y is a function of x. V is a function of x. If you differentiate v, you have the v ds. Do you understand? So that's how to differentiate. You differentiate the y ds, use product rule. This is u, the v ds, this is the v is s, differentiate s, the answer is 1 plus v s, the u ds, but u here is v, so v, differentiate v, the answer is the v ds. So that is the y ds will be equal to what? V plus what? S dv ds. So that is, let's call this one equation 2c. The y ds equal this, the y ds equal this. So equate the two. Look at it. The y ds, actually the y ds must be equal to what? The y ds. Are they not the same thing? The y ds equal the y ds. What is the y ds from equation 1? Where do I see plus? So this is minus. Do you understand? So it's not plus. So this is minus. Do you understand? So now the y ds is what? Minus 1 minus 3v squared all over 2v is equal to the y ds I have here is what? V plus s dv what? ds. That is what I have. So equating the two of them. So bring all the v. Look at what will happen after that. Bring this v to the other side. I have minus 1 minus 3v squared all over 2v. This v is coming, it becomes minus v is equal to what? X dv dx. That is what I have. Now find the LCM here. The LCM here is 2v. 2v divided by 2v, 1 times all this, minus 1 minus 3v squared. This one is over 1. 2v divided by 1, 2v times v, 2v squared is equal to x dv ds, right? Minus 3v squared minus 2v squared, that's minus 5v squared. So this is minus 1 minus 5v squared all over 2v is equal to x dv ds. Do you understand? So now you can see that it is now variable separable. Bring all the x to the other side and take all the y to the other side, or better to cross multiply so that it will be obvious. Let me factorize this minus. I have 1 plus 5v squared ds, isn't it? When you cross multiply, that's what you have, is equal to 2vs dv. Bring this, let this s come here, let this one go there. So you have the s over s equal what? 2v over minus 1 plus 5v squared dv. So you see it's now variable separable. So I'll solve by a variable separable method. So this, integrating both sides, I have integral of the s over s is equal to integral of minus 2v. That minus can come up, plus 5v squared dv plus c. Don't forget you can have plus c. Integrate this is ln s or log s. Ln x equal, now if you differentiate what is at the denominator, the answer is 10v, but I have 2v here, so let this minus first come. I put 1 over 5 here, integral of 10v. Do you know how I normally get this? Multiply, what will you multiply to 2 that will give you 10? 5. So you multiply it by 5 and divide it back. 10v over 1 plus 5v squared dv plus the c. I told you you can leave it like this, or do you understand my point? Now this is ln s, or you can write ln k. That's what I want to say. Minus 1 over 5. If we integrate this one, if you differentiate what is at the denominator, that's 10v, and you have it on top. So the answer is ln of what? 1 plus 5v squared plus c. And see, you are true. But don't forget, the question you have here, v is not there. Remember to substitute back. v is what? Y over x. You know you are the one that led v to be y over x. You are the one that brought it in when you are solving it. So recall that you brought it in and take it out back. V is y over x. Anywhere you see, you put y over x. So this is ln s equal minus 1 over 5 ln 1 plus what? 5 v square. V is what? Y over x. That's y square over x square plus c. When you get to this point, leave your answer like that. Don't be simplifying, leave it like that. But if you know how to simplify, if you can simplify, you can continue to simplify it. Do you understand? Make sure you don't make mistake, because if you make mistake, you lose point. But if you stop here, this is an answer. You will get your full marks. The second one, without wasting time. So the second one, without wasting time, B. Now y square plus 2xy ds minus x square dy is equal to 0. Again, actually, I don't need to waste time. This is not variable separable. If you are in the examination hall and you see this equation to solve, it is check whether it is variable separable. If it's variable separable, use variable separable method and solve the differential equation. But it is not variable separable. If it's not variable separable, check whether it is homogeneous. If they don't ask you to test for homogeneous, start solving. If you can see that it is homogeneous, start solving it. Do you understand? But if you see that it is not homogeneous, and you see that if they ask you to show that it is homogeneous, you will do this. If you are told to show that it's homogeneous, you will do this, and you can see you will get the degree. Do you understand? But if you are not told, start solving it. I know this is homogeneous, you understand, because it's part of the example I want to solve. It's homogeneous. I don't need to show it again. Now, if I don't need to show it again, then how do I start? Bring this one to the other side. I have what? Y squared plus 2xy dx equal x squared dy. That is what I will have first, right? Now, find the y dx. So this one will be y squared plus 2xy all over x squared is equal to what? The y dx. So do you understand what I'm doing? Make the y dx the subject of formula. That's the first thing. So the y dx equal all these other ones to be here. Do you understand? Just you understand what I'm saying. Now, what is the next thing? When you get to this point, you will what? How do you solve for homogeneous equation? That's what you should remember. When an equation is homogeneous, how do you solve for it? Let v to be equal to what? Y over x, and y will now be equal to what? Vs. You are still coming back to this, but anywhere you see y, you go and put vs there. So that means the y ds will be equal to what? Y square. Y square, that's v square s square plus what? 2s vs. Anywhere you see y, put vs. Y square is what? Vs all square, which is v square s square plus 2s. Y is what? Vs. You can see all over what? S square. Now the y ds is equal to what? V square s square plus s times s is s square, so plus 2v s square all over what? S square. S square can be factorized at the numerator. S square, you will be left with what? V square plus 2v all over s square. So s square will cancel s square. You will be left with what? The y ds is equal to what? V square plus 2v. That's what you will be left with. Do you understand? So now, come back to this one. Come back to it. Y equal what? Vs. Differentiate this one. Don't forget. Differentiate y. The y ds. You use product rule. V, take v, differentiate the second one, 1, plus the second one s, differentiate the first one, dv over ds. That is what you have. So that means the y ds, and please take note, v plus x dv ds. Whenever you've gotten to this place and you want to differentiate, this is the answer. This is always the answer. The y ds equal v plus s dv ds. It is always the answer. Do you understand? So That is always the answer. Now the y ds is equal to this. You know, after that, don't forget, let me tell you one thing about homogeneous equation. Once you know that it's homogeneous, let v be equal to y over x. Substitute y to be vx. After substituting, the y ds will just be a function of v. If there is any other thing here, you have done rubbish with confidence, it will not work. Every homogeneous equation, when you put y to be vx, what you will get, x will cancel out. Do you understand? X will cancel out. You will be left with something like this. Do you get that? So that is one thing you need to note. You need to take note of. Do you understand what I'm saying? So everything that will remain must be a function of v, and by the time you differentiate this, you will have this. After that, you will equate the two dy ds, equating the two of them. I have the y ds here is what? V squared plus 2v is equal to the y ds of that one is what? V plus s dv ds. Bring this v to the other side, you have v squared plus 2v minus v equal s dv ds. That is what you are going to have. Now this is v squared plus v is equal to what? S dv ds. Now this is over 1, cross multiply. You will be having 1 times this is s dv equal v squared plus v ds. Don't forget, whenever you are, see, after substituting after substituting this one and you've equated the two the y ds, the equation you are going to get must be variable separable. Do you understand? In fact, another name they normally call homogeneous equation is equation reducible to variable separable, because after you substitute this, it will reduce to variable separable. Do you understand? Now let's continue. So bring this one will be dv over what? V squared plus v equal what? ds over s. So you see, variable separable. Integrate now. This is dv. Factorize the denominator. I have v open bracket v plus 1 equal integral of dx over s plus c. You can see that I told you can write in k or in anything if you want to simplify further. Now this is 1 over, you see, if I remove this is 1 over v. This, whenever you have something like this at the denominator, v open bracket this, how to differentiate this is that you will resolve it into partial fraction. You will resolve this into what? Partial fraction. Do you understand? You know how to resolve into partial fraction? You quickly do 1 over v open bracket v plus 1 equal a over v plus b over what? V plus 1. So clear fraction, multiply through by v plus 1. When you multiply by v plus 1, this one will remain 1. See, this one will have the denominator of the second one, v plus 1, plus this one will have the denominator of the first one. Now, to get a, let this one be 0. So, what is beside b? V. Just put v to be 0. So, anywhere you see v, put 0. So, this is 1 equal v plus 1, 0 plus 1, 1. 1 times a. But this one is what? 0. 0 times anything 0. So, you've gotten a to be 1 like that. Do you understand? Now, to get b, a must be 0, and what is beside a? V plus 1. Put v plus 1 to 0 as well. Solve for v equal what? Minus 1. So that means put v to be minus 1. Anywhere you see v, put minus 1. So this is 1 is equal to minus 1 plus 1 is 0. 0 times a is 0. So minus 1 times b minus b. Multiply both sides by minus 1. Bring b here and take 1 to the other side. You will see that b is equal to what? Minus 1. So that means I have resolved this into partial fraction. This 1 over v plus 1 open bracket v minus 1 is what? A over v plus b over v plus 1. What is a? A is 1. A is 1. So that means this is 1 over v. B is minus 1. That's why I put minus. Minus 1 over v plus 1. So you can confirm whether this your partial fraction is correct. Find the LCM again and join it together. You must get this. Do you understand? So this is equal to integral of ds over s plus c. Now integrate 1 over v. The answer is what? Ln v. Minus integrate 1 over v plus 1. The answer is what? Ln v plus 1 is equal to the integrate ds over s. The answer is what? Ln s. Don't forget, if you differentiate the denominator, if you get what's at the denominator, the answer is ln of that denominator. So differentiate x, the answer is 1. It is 1 that is on top. If you take away the ds, it is 1. So plus what? Plus c. And you are true, but don't forget, v is what? Y over s. You must put it back. This is ln of what? Y over s minus ln of y over s plus 1 equal what? Ln s plus c. You can leave your answer like this. You are true, and that will be the answer. Let's go to another part of first order differential equation. Click the like, subscribe button and help me share this. Thank you very much. Yes, now exact equation. We are now on exact equation. Now the differential equation mxy dx plus nxy dy equals 0 is called an exact differential equation in domain D if there exists a function f of two real variables x and y in D, so that the f dx equal m of xy and the f dy is n of xy for all x in this. Now this is just the definition of an exact differential equation. They say the differential equation mxy dx plus nxy is called an exact differential equation in a domain if there exists a function f of two variables, so that if you differentiate, if there exists a function f, do you understand, another function capital letter f, so that if you differentiate that function with respect to x, you will get m of xy. You will get m of xy. If you differentiate that function with respect to y, you will get n of xy. They will say it is exact. So, but then if you are given a differential equation giving ms comma y ds plus ns comma y dy equals 0, that is like, that's, I call it one. This is a differential equation. So how do you check whether a differential equation is exact? Number one, look at it. Let me tell you something. You know, I have done variable separable. A differential equation is said to be variable separable. You know it. Homogeneous, we just finished homogeneous now. Now for exact, when we are talking about exact, you know, you can check for homogeneous. You can also check for exactness of a differential equation, because before you solve an equation in a way, because an exact equation has a way you will solve it. Now a differential equation is exact if and only if the m dy, what is the m? Let me tell you, when you have two things, you know, you have m ds plus n dy equals 0. Do you understand? Now this m is a function of x and y, mx comma y ds plus ns comma y dy. Now what is like, what the let me call it this way. The coefficient of ds is called m. You know, of course, you know it's not a coefficient, it's a function of x and y. The coefficient of y is called n. Do you understand? Now if you now take the coefficient, you know, don't forget it is with respect to x. If you take the coefficient of that dx, m, and differentiate, don't see what is beside it, ds. Don't differentiate it with respect to ds again. Differentiate it with respect to dy. If you take this one that have ds, like m, what is the coefficient of ds? Differentiate it with respect to y. Do you understand? With respect to y. Take this one, the one coefficient of dy, m. Differentiate it with respect to what now? Don't differentiate it with respect to y again. Differentiate it with respect to s. Do you get that? If they are the same, then the differential equation is exact. Do you understand? So that's what this one is saying. Given this differential equation is exact if and only if the m dy equals the m dx. Now example, let's see how we are going to solve. Look at the first example. 3x squared plus 4xy ds plus 2x squared plus 2y dy equals 0. Do you get that? So this differential equation is actually not variable separable. That's number one. Number two is that it is not homogeneous. Yes. The second one is that you can check it. You can pause the video and check it. Make the y ds the subject of formula and put tx there and see whether you can factorize the tx out, and all the, you know, the condition, the requirement for a differential equation to be homogeneous. Check it, you will see that it is not homogeneous. Now The next thing is that whenever you are in the examination, if a differential equation is not variable separable, if it's not homogeneous, check whether it is exact. Now, how do you check whether a differential equation is exact? Or M. What is M? This is M. What is beside the S? In fact, they can see another question can come this way. So take note. Like you can have 2x squared plus 2y dy plus 3x squared plus 4xy dx equals 0. Look at this one. How will you know M? Go and look for ds first. You need to first check for ds. This is ds. So what is like I call it, the coefficient of ds is what? Your M. The coefficient of dy is your M. Do you understand? So now go and look for ds. This is ds. So coefficient of ds is what? 3x squared plus 4xy. And the coefficient of dy is what? N. N is 2x squared plus 2y. Now don't forget, no, this is the s beside it. Don't differentiate with respect to ds again. I'm saying this so that you will remember, because some people will not know whether it's the m ds or the m dy in the examination hall. So just this how to know. Since it's the s that is beside m, that means you will not differentiate it with respect to x again. Differentiate it with respect to y. Differentiate this thing with respect to y. Partial derivative with respect to y. This one does not have y. See, any other thing that is different from y is a constant. This one does not have y, so it's a constant. The answer is 0. If you differentiate 3x squared with respect to y, this one does not have y. Anything that does not have y is a constant, and if you differentiate it, the answer is 0. So differentiate 3x squared with respect to y, this is 0. Differentiate this one. Imagine differentiate 4as. What is the answer? The answer will be 4a. Do you understand? The same thing happened here. This 4s is like a constant. It's like 4a. Then you now have y raised to power 1. Differentiate y. The answer is 1. So 4a times 1, 4a. Do you understand? So differentiate 4xy, partial derivative. The answer is what? 4s. Now come here. Now you differentiate this one with respect to y. Besides, this is the y. So differentiate this one with respect to x. Differentiate with respect to x. Differentiate 2x squared. The answer is 4s. This one does not have s. If you differentiate it, the answer is 0. So you can see the m dy and the n ds, they are both what? 4s. They are the same. So this, you can see that the m dy is equal to the n ds. So they are what? The same. Therefore, the differential equation is what? Is exact. Therefore, the differential equation is exact. So that is it. When you are given an exact differential equation, you have to show that it is exact. It is compulsory for you to show that it is exact. So therefore, the differential equation is exact. So what do you do now? Come back here. Come back to the question. Open the bracket. Open the bracket. So this is what? 3s squared ds. Do you see that? Plus 4xy ds, right? Plus, open the bracket, 2x squared dy plus what? 2y dy equal to 0. So you will integrate them individually. So integrate this one. This is integral of 3x squared ds plus integral of 4xy ds. You will integrate this one again plus integral of 2x squared dy. You integrate this again, integral of 2y dy. If you integrate a constant, the answer is c. Now let me show you something. I need to tell you something now. After you've written this, we are still on this line. You will not check one after the other, the one that have two variables. You will see what we have. This is 3x squared ds. They are all one variable throughout. Leave it. This is 4xy ds. I can see y. I have x and y inside there. Anyone that have x and y that have two variables, put half in front of it. Put 1/2 in front of it. This is 2x squared, but it is what? Dy. Put half in front of it. This is 2y dy. it's just one variable throughout, leave it. Now integrate 3s square, you know how to integrate. This one will give me what? S raised to power 3. Do you get that? Differentiate s raised to power 3, you get 3s square plus. Now let me show you something here. I'm integrating with respect to what? The s. Anything that does not have s is a constant, so that means this 4 and y is a constant. Let them come out. I will have 4y over 2 integral, it will just remain only s ds plus. Now I'm integrating with respect to what here? Y. So this 2s square is a constant, it can come out. This is 2s square over 2 integral of what? Dy plus. Now integrate 2y, the answer is what? Y square equal to what? C. Now this is s raised to power 3 plus 2 cancel 2 here 1, 2 here 2, this is 2y multiplied by differentiate s. I mean integrate s, the answer is what? S square over 2. I hope you understand how I'm doing it. Don't forget, you will be adding 1 to the power, you have what? S raised to power 1 plus 1 over 1 plus 1. That's what you will do, isn't it? Do you remember? Plus 2 cancel 2, you are left with s square. Integrate dy, the answer is just what? Y plus y square equal to what? C. Now I have s square, 2 cancel 2, that's out. Y times s square y plus what? Another s square y plus what? Y square equal to 0, so equal to C. So s square plus s square y plus s square y, the answer is 2s square y plus 2s square y plus y square is equal to C. So this is the answer, or this is how to solve an exact equation. So now the second question, the same thing you already see now. This is 2s square, this is 2xy plus 1 ds plus s square plus 4y dy equal to 0. M is, as I've been calling it, coefficient of ds. N is coefficient of dy. So what is m? M is 2xy plus 1. Differentiate it with respect to what? Dy, because this is x already. So with respect to y, I told you anything that is not y is a constant. Differentiate 2xy, the answer is what? 2s. That is 2x. No, this one is like a constant. Like differentiate 4y, the answer is 4. So differentiate 2xy, the answer is 2s. What is n? N is s squared plus 4y. Differentiate it, the n, the s. With respect to s, you know why? I've explained this already. Differentiate with respect to s, the answer is what? 2s plus 0, because it does not have s. You see that they are the same. The m dy is equal to what? The n ds. Therefore it is what? Therefore it is exact. So since it's exact, what do? Open the bracket. So this is 2xy ds plus ds. Open the bracket. 2xy ds plus ds plus I have what? S square dy plus 4y dy equal to 0. So integrate individually. This is integral of 2xy dx plus integral of ds plus integral of s squared dy plus integral of 4y dy is equal to C. When you integrate 0, you will have a constant. So don't forget what I told you about. This one has two variables, 1 over 2. This one is just one. This one has two variables, 1 over 2. So, and that's all. Do you understand? So integrate it. I told you before, when 2y will come out here, because I'm integrating with respect to s, so that means 2y is a constant. 2y will come out, you'll be left with y integral of s ds plus integrate ds, the answer is just x. This is plus 1 over 2s square integral of what? Dy. Do you understand? Plus this one is what? 2y square equal to C. That is what you have. So if we integrate this one will be what? S square over 2. That is s square y over 2 plus x plus this one too. 1 over 2s square y plus 2y square equal to C. S square y plus S square y. The answer is S square y. S square y over 2 plus S square y over 2. The answer is S square y plus x plus 2y square is equal to C. And that is all for what? That is all for what's the name? That is all for exact equation. Let's go to the next one. It's for the linear equation. I'm now in linear equation now. I have done homogeneous. I have done variable, separable, homogeneous, and exact equation. Now I am in linear equation. Linear equation. If a differential equation is written as dy dx plus p of xy plus is equal to p of x, then it is said to be what? A linear equation. So a linear equation, number one thing you need to take note of in a linear equation is that it is written where it is written this way. You need to take note of that. That a linear equation is written this way: dy dx plus p of xy equal q of s. Then it is said to be what? A linear equation. Now, to solve, if you want to solve a differential equation, a linear differential equation, you will first find what we call IF. IF means integrating factor. And what is integrating factor? E raised to the power of integral of p of s. What is p of x? P of x is that coefficient of y. This is p of x. Do you understand? So integral of p of x ds, integral of p of x ds, e raised to power integral of p of x ds. That is what we are talking about now. The solution to solve it. Now the solution of the differential of this linear differential equation will now be y. This is the solution. The answer is y multiplied by what? The answer you get from that integrating factor is equal to integral, open bracket, integrating factor times q of x ds plus c. That's all. Now example. Look at the first example. Dy dx plus 1 over xy equals sine s. Life has been made simple because you can see dy dx. You see that, notice that there is no coefficient with, there is nothing with there is no coefficient with the dy dx. The coefficient of dy dx is 1. It must always be 1. Dy dx plus 1 over xy equals sine s. So it is obvious that this will be your p of s. What is beside y will be your p of x. Then what is here will be your what? Q of x. Do you understand? So that means my p of s is 1 over s, and my q of s is sine what? Sine s. So what is the next thing to do? I told you to solve. Find integrating factor. Integrating factor will be equal to e raised to power integral of p of s ds. E raised to power integral of what? 1 over s ds. If we integrate 1 over s, the answer is what? Ln s. And e raised to power ln, whenever you have e raised to power ln, the answer is what is in front of that ln. I hope you know that. E raised to power ln is if you say e raised to power ln 5, the answer will just be what is in front of that ln. That's the answer. So e will cancel ln, it will remain x. That's my point. Ln x. The answer is x. Do you get that? Now the next thing is what? The solution. What is the solution? I said that the solution from here, let me write it out again, is y first multiplied by the integrating factor is equal to integral of integrating factor times what? P of x ds plus c. Right? So what is y multiplied by what? Integrating factor is what? S. Sorry for the interruption. As far as this board is still showing, we go finish am today. Now what is integrating factor? X. I have open bracket. Integrating factor is what? X multiplied by what? Q of s. Q of s is sine s ds plus c. So y times s is ys or xy is equal to, now you have integral of what? S sine s ds plus c. So I have xy equal, you will do this one integration by parts. You will use integration by part to integrate this. It will let u to be s and dv to be sine s. Do you understand? So ds. So you will differentiate and use integration by part. So I'll use one shortcut. Let me just show you the shortcut. If you can get it, get it. If you don't understand the shortcut, then use the long cut. You get my point. Now look at what will happen. This one, we will have s. Write it. Integrate sin x. What is the answer? If you integrate sin x, the answer is minus cos x. Another, like, what will you differentiate that will give you sin x? The answer is minus cos x. So that's minus cos s. Do you understand? Now look at the next thing. The next thing, I said that take s. This is s. Integrate sin x. You first write the first thing. Integrate the second thing. Integrate sin x. The answer is minus cos x. You will now have minus. Do you see that? Now the first thing you take here, differentiate x. 1. Integrate what is inside. So let me tell you the secret. The secret behind what I'm doing here is that, let me just show you here briefly, is if you want to integrate, let's say maybe u dv, or no, let me just say I have two things here, u and maybe v ds, like something like this. Here my u is this one. If you want to use integration by parts to solve this one, you will have to identify your u and your v. You get my point? So you will first take this first thing, u, integrate the second thing. You see, integrate the second thing. Do you understand? Minus. The next side I will follow will be minus. You will be differentiating what is here, that u, minus, differentiate that u, integrate the second thing. That means you'll be integrating it the second time, something like that. Then after you write one, the next line will be plus, the next line will be minus, the next line will be plus, the next line will be minus, till you stop, till you get to a stop. You see when you are going to stop. But how do you do it? Now listen. What will happen is that, when you have this, let me talk about the sign first. When you have this, the next sign will be minus. The first sign will be plus. Next sign minus. Next sign plus. Next sign minus. Next sign plus. Next sign minus, till you stop. Now, the first thing I told you, the first thing inside the integral, this u, that is what you write first. The second thing, you will integrate it, the answer, you write it beside it. Then the minus, you will be differentiating this one, you will be integrating the second one. When you get to this one, you will differentiate this one again, integrate the second one, differentiate the first one, integrate the second one. That is the shortcut for integration by parts. So in this case now, this is the s, write the s. Integrate sin x, the answer is minus cos x. Minus, I told you, the first sign will be plus, the second sign will be minus. Differentiate s, the answer is what? 1. Integrate cos x. If you integrate cos, the answer is sine. So integrate minus cos x, the answer is minus sine s. If you want to know whether you are correct, the answer you get, differentiate minus sine x. If you differentiate sine, the answer is cos. So differentiate minus sine x, the answer is minus cos, which is what you have here. You see, after the next time what? Plus. Differentiate 1, 0. That's where you stop. That's how you know where you will stop. Do you understand? So I'm done integrating this, plus c. So this is xy. Open the bracket. This is minus s cos s. Right? Minus times minus plus sin s plus c. You can leave your answer like this, or you might decide to divide through by x, so that if you want to make y the subject of formula, just divide through by the integrating part of which is x. So y will now be, this one will now be minus x over this one will remain cos s plus sin s over s plus c over s. That would be the answer. Whichever one you are writing is correct. Now let's move to the next one. Let's move to the next question. Number 2. I have x dy dx plus 2x squared y is equal to 4x squared. What will happen here is that, don't forget, for a linear equation, the coefficient of x must be what? 1. So this the coefficient of the y dx must be 1. So divide through by s. So if you divide this one by s, you will be left with the y dx, divide through by s, plus, by the time you divide this one by s, this one will be 2xy is equal to what? 4x. Do you understand? That is what you are going to have here. Now, what will happen? Check whether it is of that form. So it is actually of that form because it's obvious. P of s, this is P of s, this is Q of x. Do you understand? So the y ds plus P of s y is equal to Q of x. So P of s is what? P of s is 2s, Q of s is this 4s. Do you understand? So that is what we have. Now let's integrate. Before we do that, no, you are already seeing that this is a linear equation, right? It's obvious now that this is a linear equation. Now, what is the next thing for you to do? Find the integrating factor. Please don't forget. Find the integrating factor. What will be the integrating factor? The integrating factor will be equal to e raised to power integral of what? P of s ds. This is e raised to power integral of P of s is what? 2s ds. If we integrate 2s, the answer will be what? S squared. So the integrating factor here is e raised to power s squared. So what is the solution? Don't forget, y multiplied by the integrating factor is equal to integral of open bracket integrating factor times Q of s. You have to remember this formula. This is what we have to plus c. So I have y multiplied by integrating factor is e raised to power s squared is equal to integral integrating factor e raised to power open bracket e raised to power s squared multiplied by e raised to power s squared multiplied by Q of s. Q of s is what? 4s ds plus c. So open the bracket. This is y e raised to power s squared equal integral of this one will be 4s e raised to power s squared ds plus c. So you will have to integrate this one. Let me just show you how you will integrate it. To integrate this one, what will be your answer? You will let u to be equal to something. Let me write it here. To integrate this, integral of 4s e raised to power s squared ds, right? Let u be equal to s squared, right? Du ds will be what? 2s ds. Make ds the subject. Ds will be equal to du over what? 2s. So this one will now be integral of 4s multiplied by what? E raised to power u, because s squared is now u. Multiply. I'm using integration by substitution. Ds is what? Du over 2s. Du over what? 2s. S cancel s. 2 here 1, 2 here 2. So you have to integral of e raised to power u du. And if you integrate e raised to power u du, what is the answer? The answer is e raised to power u, isn't it? Because if you differentiate e raised to power s, the answer is e raised to power s. E raised to power u, the answer is e raised to power u. So that means the answer is what? 2e. What is u? S squared. So the answer is 2 e raised to power s squared. So that's what you will have. So this is y e raised to power s squared equal, if you integrate this is 2 e raised to power s squared plus c. You can leave your answer like this, that's all, or divide 2 by e raised to power s squared. If you want to make y the subject of formula, divide 2 by e raised to power s squared. You have y equal to, because if you divide by e raised to power s squared, it will cancel, plus c over e raised to power s squared or e raised to power minus s squared. Whichever one is fine. Let's go to the next one. So now we are now in Bernoulli equation. Bernoulli equation. Now let me tell you what happened here. A Bernoulli equation is very similar to a linear equation. A Bernoulli equation is similar to that of a linear equation. Now, an equation of the form, you have a linear equation. How does a linear equation look like? A linear equation look like dy ds plus p of x y equal q of x. Now, how does a Bernoulli equation look like? Dy ds plus p of x y equal, instead of just q of x, you now have y raised to power n, y raised to power something q of x. Do you understand? So the difference between linear and Bernoulli is because of this y raised to power, n. Do you get that? So that is all the difference. So that's why I say it's very similar to that of a linear equation. Now, an equation of the form dy ds plus p of xy equal y raised to power n q of x is called a Bernoulli equation. Now, from here, now write out the Bernoulli equation from dy dx equal p of x y equal y raised to power n q of x. The first thing you are going to do is that you will find a way of writing it. You find a way of how you will change it back to a linear equation. That is the point you are doing here. The essence of what you are doing here is that find a way of how you will take it back to a linear equation. And to do that, see, the first thing you are going to do, you will first divide through by this y raised to power n. You know, this y raised to power n, divide through by y raised to power n, that is the y ds 1 over y raised to power n. Do you understand? I'm dividing through, divide each of them. This one will be p of x y raised to power 1 n minus 1 equal what? Q of x. Divide through by y raised to power n. This is what you will get. Another way I can write it from law of physics, this is y raised to power minus n dy ds plus this one y raised to power 1 minus n p of s equal what? Q of s. That is what you are going to have. Do you understand? That is what you are going to have. So we have this. Divide through. You see that? So after dividing through, you will now let v to be equal to y raised to power 1 minus n. See, look at the p of x. What do you have beside it? Y raised to power 1 minus n. Let v be that thing. So let's see how we are going to solve it now. I have two examples here. Solve the y ds minus y equals y raised to power 5. The second one, solve x y dy plus y ds is equal to x raised to power 3 y raised to power 6 ds. Do you understand? So that is what we are going to, or that is what we want to do now. Look at the first equation. The y ds minus y equal x y raised to power 5. So the first thing is that, as I said earlier, take away this what? Y raised to power 5. Divide through by y raised to power 5. What do you have? This one will become 1 over y raised to power 5 dy ds minus this one will be 1 over y raised to power 4, because one of the y would have cancelled. It is equal to x, or another way of writing it, y raised to power 5 minus the y ds equal, you have this minus y raised to power minus 4 equal x. Now, the first thing you need to know is, what is your p of s here? Your p of s is actually 1. Do you understand? If you don't forget, it will become y raised to power 1 minus n p of s. This y raised to power 1 minus n is this y raised to power 4. So, and nothing is there. So, p of s is 1. Q of s is x. Do you understand? But then, we don't need that now. What do we need? I told you, you will let v to be equal to y raised to power, you will let v to be equal to what is beside p of s. Note, p of s here I told you is 1. Y raised to power minus 4 times 1. So y raised to power minus 4. So you will let v to be equal to this y raised to power minus 4. Y raised to power minus 4. Now, differentiate with respect to s. dv ds is equal to, if you differentiate this one, what will it be? Minus 4, right? Y raised to power minus 5. Don't forget, but you differentiated y. You know, the power will come down minus 4, y raised to power minus 4, then you subtract 1 again, it becomes minus 5. But you differentiated y. When you differentiate y, what will happen? Add the y ds. Do you see that? That is what we have. Now, divide both sides by minus 4. Divide both sides by minus 4. This one will become what? Minus 1 over 4 dv ds is equal to the minus 4. The point is that take away this constant. Minus 1 over 4 dv ds equal what? Y raised to power minus 5 dy dx. So substitute into this equation that you have here. Before you let v, you are here. Before you let v, y raised to power minus 5 dy ds, y raised to power minus 5 dy ds, the answer is what? The answer is minus 1 over 4 dv ds. So put it there. This is the question. I just divided through by y raised to power minus 5 and I let v to be this. Substitute back. After differentiating, after getting dv ds, substitute. Y raised to power minus 5 dy ds is equal to this. So this is y raised to power minus 5. It becomes minus 1 over 4 dv ds minus y raised to power minus 4 is what? V. Minus v equal what? S. Now, I told you it's already looking like a linear equation, isn't it? Now, clear this minus 1 over 4. Multiply through by minus 4. If you multiply this one by minus 4, you know 4 becomes 4, minus becomes minus, it becomes plus. Dv ds minus times minus plus 4v is equal to what? Minus 4s. Now what do you notice? If you look at this one, if you remember, dy ds plus p of s y equal q of s. This is what? A linear equation, isn't it? This is actually a linear equation. But now if I change this y to v, then I have, that means this y2 will become what? V. It's still a linear equation. Do you understand? And the solution will just be anywhere, you know, the solution of this one is what is it called? Of a differential equation is y integrating factor equal integral of integrating factor times q of s. You know it, right? So the point is that anywhere you see y, change it to v. So this is dy ds plus 4y equal minus 4s. Do you understand? So this is dv ds plus 4v equal this. So this is my point is this is a linear equation, but instead of having y, you have v. So what is your p of s? Don't forget, your p of s is what is beside y here, but it is now v. So you should see it. Your p of s is 4. What is your q of x? Your q of s is minus 4x. So find integrating factor. What is the integrating factor? Integrating factor is what? E raised to the power of what? P of s ds, which is e raised to power integral of 4 ds. If you do e raised to power integral of 4 ds, the answer is what? E raised to power 4s. That is your integrating factor. Now, what is the next thing? The solution. You know, the solution of this one will now be v multiplied by integrating factor. Don't forget the y has changed to v. That's all. V multiplied by integrating factor is equal to what? Integral integrating factor times what? Q of x ds. Don't forget plus c. So substitute into it. In fact, another name they call Bernoulli equation is equation reducible to linear. So this is v multiplied by integrating factor e raised to power 4x is equal to what? Integral of open brackets integrating factor is e raised to power 4s multiplied by what? Q of s. Q of s is what? Minus 4s, right? ds plus c. That is what you have. So this is v e raised to power 4s is equal to what? Integral of minus 4s e raised to power 4s ds plus c. So this is v e raised to power 4s equal minus 4 integral of s e raised to power 4s ds plus c. You will also use integration by part again. U will be s, the v will be e raised to power 4s ds. So this is v e raised to power 4s. Actually, to solve a differential equation, you must be very good at differentiation and integration. Now, that method I used the other time, that's what I'll use. Take the first one s, integrate the second one. If you integrate e raised to power 4s, what's the answer? 1 over 4 e raised to power 4s. Right? What's the next sign? The next sign is minus. Differentiate this one, 1. Integrate what is inside here again, that is 1 over 16 e raised to power 4s. If I differentiate 1, the answer will be 0, so I stopped here. Plus what? Plus c. So this is v e raised to power 4s equal what? Open the bracket. Minus 4 times this one, it will cancel. So you'll be left with minus s e raised to power 4s. Minus times minus will give me plus. 4 divided by 16, that's 4. So I will still have 1 over 4 e raised to power 4s plus c. You might leave your c. You have to change this v. What is v again? V is y raised to power minus 4. Do you get that? Because v is not in the question you are giving. Y raised to power minus 4. You can just divide through by e raised to power 4. If you divide through by e raised to power 4, you get v equal what? Minus x plus 1 over 4, because it will cancel out. Then you have plus c e raised to power minus 4x. What is v? V is y raised to power minus 5. So y raised to power minus 4 rather is equal to minus x plus 1 over 4 plus c e raised to power minus 4x. You can leave your answer like this. You are true. Once you can leave your answer like this, or you decide to write 1 over y raised to power 4 equal this. Anyone you want to write is correct and fine. Do you understand? So let's quickly go to the next question. The next question is saying that what? I have s dy plus y ds is equal to what? S raised to power 3 y raised to power 6 ds. Divide through by ds. Divide through by ds, you have s dy ds plus y equal s raised to power 3 y raised to power 6. This would have been a linear equation, but because of this y raised to power 6, don't forget. So divide through by y raised to power 6. Do you understand? Divide through by y raised to power 6. You should still be able to recall the general form of a Bernoulli distribution. The y ds plus p of sy equal, the p of s here is 1. The q of s here is s raised to power 3. So this y raised to power n is y raised to power 6. So divide through by y raised to power 6. So this no. I think the first thing I need to do here is actually to remove this x. The y ds must be empty. See, the y ds the coefficient of the y ds must be 1. So divide through by x. You have the y ds, right? Plus this one will now be 1 over xy is equal to what? S square y raised to power 6. Now the next thing is that what? Divide through by y raised to power 6 now. Since the y ds is now 1. So divide through by y raised to power 6. This one will become y raised to power minus 6 dy ds plus this one will be 1 over 5 y raised to power minus 5. You know, if you have y over y raised to power 6, you know, this is 1 over y raised to power 6. I can write it as y raised to power minus 6. This one, y over y raised to power 6, this is 1 over y raised to power 5 is equal to s squared. Y raised to power minus 6 dy ds plus 1 over s, this is y raised to power minus 5 is equal to s squared. Don't forget your p of s is this 1 over s, your q of s is s squared. So again, let what? Let v be equal to what is beside your p of s? Y raised to power minus 5. Differentiate. dv ds is equal to what? Differentiate y, this is minus 5 y raised to power minus 6 the what? The y ds. Do you understand? That is what you have. So divide both sides by minus 1 over 5. So this is minus 1 over 5 dv ds is equal to what? Y raised to power minus 6 dy ds. Do you get that? So now come back to this place. Before you make v the subject of formula, come back to this place. Substitute into it. Substitute into the question. Y raised to power minus 6 dy ds. Y raised to power minus 6 dy ds is minus 1 over 5 dv ds. So it becomes minus 1 over 5 dv ds, right? Plus 1 over s. Y raised to power minus 5 is what? V. V equal what? S squared. So this divide multiply through by minus 5. This one times minus 5 is minus times minus will become plus. 5 will cancel 5. You will be left with what? Dv ds multiply through by what? I'm multiplying through by minus 5. So that's minus 5 over x v equal what? Minus 5 s squared. That is what you will have. So now this is now a linear equation. In fact, your p of s is minus 5 over s. Your q of s is minus 5s squared. So now let's finish this game. So what do you have? This one will become, now your p of s is what? Minus 5 over x. Your q of s is minus 5s squared. So after I'm done with this example and you don't understand very well, backward the video and check it again. Do you understand? So now what do I have? You have to find the integrating factor. Integrating factor is what? E raised to power integral of p of x ds. So this is e raised to power integral of what? What is p of s? Minus 5 over s ds. So this is e raised to power integral of minus 5 ln s. Do you understand? minus 5 will come outside the integral. You will be left with integral of 1 over x. Integral of 1 over x is ln s. So this will become e raised to power ln of x raised to power minus 5. That's what it will become. Ln of x raised to power minus 5. E will cancel ln. The answer will be what? X raised to power minus 5. That is your integrating factor. So what will be the solution? Don't forget v. Instead of y, don't forget I've changed it to v. V integrating factor equal integral of integrating factor times what? Q of x ds plus c. V, what is the integrating factor? X raised to power minus 5 is equal to integral of x raised to power minus 5 times q of x is what? Minus 5x squared ds plus c. Now this is v over x raised to power 5. Now this is minus 5 can come out, is a constant. From law of indices, s minus 5 times this plus. Minus 5 plus 2 is what? Minus 3. Do you understand? Or 1 over x raised to power 5 times s squared. You will be left with 1 over x raised to power 3, which is s raised to power minus 3 ds plus c. And when you want to integrate that, what will it give you? This will give you minus 5 s raised to power minus 3. Don't forget, you will add 1 minus 2. When you are integrating, we add 1 to the power, it becomes minus 2 all over the whole of the power minus 2 plus what? C. So that this one will become v over x raised to power 5 equal 5 over 2x times 1 over x squared. Do you understand? Minus cancel minus, 5 over 2. X raised to power minus 2 is what? 1 over x squared plus c. Now multiply through by x raised to power 5. Let this one go there. So that v will be equal to what? 5 over 2x cubed. Do you understand? When x raised to power 5 with this one, x squared will cancel from x raised to power 5 to remain x raised to power 3 plus cs raised to power 5. What is your v? V is y raised to power minus 5. So this is y raised to power minus 5 equal 5 over 2 x raised to power 3 plus cs raised to power 5. And that is the answer to this Bernoulli equation. Now we just want to go to second order differential equation with constant coefficients. Stay tuned and please remember to subscribe, I beg of you. Thank you very much. And we have come to second order differential equation. Now a second order differential equation is given as what? A2 of x d square y over the x square plus a1 of x dy dx plus a0 of xy equals 0. This is the general form of writing the second order homogeneous. When this place is equal to 0, they call it homogeneous differential equation. But if it's, at times it may not be equal to 0. Do you understand? Now, but what I'm doing now is second order differential equation with constant coefficients. Now for constant coefficient, that means you just have a2, a1 and a0. Where a2, a1 and a0 are constant, they are just maybe numbers 3, 4, 5, any number. Do you understand? Now if you want to solve a second order differential equation that is of this form that I've written, or with constant coefficients, this is what you are going to use for essentially for constant coefficient homogeneous equation, that is when the right hand side are all equal to 0. Do you understand? When the right hand side are all equal to 0, you will just let y to be e raised to power mx. That is all. That is all. And you will see how I'm going to do it and solve it now. Actually, let me tell you something. When you let y to be equal to e raised to power ms, you will get a quadratic equation. Like in the process of solving this, all the differential equation, you will arrive at a quadratic equation. And you know, a quadratic equation, you will get two answers. At times, the answer might be different. Maybe x is equal to 1 or 3. That's two different answers. Do you understand? If your answer is distinct, they are real and distinct, that is not a complex number. It is, if your answer is two different answer, what will happen? Your solution will just be, let's call it, let's call it m1 and m2. Let's call your two answer m1 and m2. If m1 is different from m2, the solution of the differential equation will be what? Y equals c1 e raised to power m1s plus c2 e raised to power m2s. It's very simple. Let me show you what is just happening there. When you get m1 and m2 and they are different from each other, the two roots are different from each other, right? you just you said that let y be equal to e raised to power ms. So that means your answer y will just be equal to this e raised to power m1 s plus e raised to power m2 s, but you just add a constant to it, like add a constant to the front here, c1, add a constant to this one. So that's why they say c1 e raised to power m1 s plus c2 e raised to power m2 x. Now if they are the same, if m1 is equal to m2, maybe you go and get m equal 3 twice, a quadratic equation, you may get the same answer, m equal 3 twice. Call the two of them the same number, call it m. What will be your solution? Your solution will just be, see, what will happen is that the first one, is e raised to power m. Your m1 is m, e raised to power mx. Your m2 is also what? E raised to power ms. What is now the difference between the two of them? That's why they say, okay, since the two of them are the same, add x to one of them. You will add the x to one of them. Do you understand? What will happen again? You don't forget to put constant c1, c2. So you can look at it that, okay, e raised to power ms is common, factorize it. So this one will remain c1 plus c2s e raised to power ms. That's why they say, okay, when you have equal answer will be c1 plus c2s e raised to power ms. Now if you have a complex answer, whenever you are solving a quadratic equation, it's possible you get a complex answer. If your answer, maybe your m is equal to a plus or minus bi, what will be your answer? Y will be equal to, the first thing is this a, it will be e raised to power this one as. You will now open a bracket. Please take note of that. c1 cos what? The second one b, don't write bi, just b, bx plus c2 sine what? bs. Do you understand? That is just the summary. Now let's solve. You will see what I'm trying to say when we are solving now. Why solving? So now look at it. What will happen here? Let y be equal to e raised to power mx. That's what you will do. Differentiate the first time. The y ds will be equal to what? M e raised to power ms. Differentiate the second time. The square y over the s square will be equal to what? M square e raised to power ms. You know how to differentiate. Just differentiate the numerator, like the power. What is here? Write it. Differentiate ms, the answer is m. Write the question. Differentiate ms, the answer is m again. That's m square. Write the question. That's it. Now substitute into this equation. So this one will become what? What is the square y over the s square? The square y over the s square is what? M square e raised to power mx minus 5 the y ds. The y ds is what? M e raised to power ms. Do you see that? Plus 6 y. Y is what? E raised to power ms equal to 0. E raised to power ms is common. Factorize this e raised to power ms minus 5m plus 6 e raised to power ms. Oh no, don't let me do it that way for you. Divide through by e raised to power ms. Divide through by e raised to power ms. If you divide through by e raised to power ms, you have what? M square minus 5m plus 6 equal to 0. See, you have a quadratic equation now. You will solve this quadratic equation. You can use calculator to solve this quadratic equation. So I'm not wasting time here. M is equal to 2 and 3. If you solve this quadratic equation, the factor is m minus 2, m minus 3. You will get it. So m equal 2 and 3 when you solve this quadratic equation. So do you get that now? So you see that this is the two answers I'm talking about. Are they the same? No. M is 2. The other one is 3. So what will now be? Don't forget your y equal e raised to power ms. So y will now be equal to e raised to power, the first answer 2x. Do you see that? Plus the second answer e raised to power 3x. Do you get that? But put constant c1, c2. You now say where c1 and c2 are constant. That's what this one is saying, that the general solution will now be y equals c1 e raised to power m1s plus c2 e raised to power m2s. That's all. Do you understand? Now let's come to the second one. For the second one, you can see the second one is the square y over the s square plus 8 dy ds plus 16y equal to 0. Again, what do you do? Whenever you have a second order differential equation with constant coefficients, let y be equal to e raised to power what? Ms. Differentiate the first time. Y prime or dy ds is equal to what? M e raised to power ms. Now mind you, after dividing through by e raised to power ms, this m square minus 5m plus 6 has a name. They normally call it auxiliary equation. You say, what is the auxiliary equation of this differential equation? It's just the auxiliary equation is just this is how to spell it, auxiliary equation. So now differentiate the second time, you have what? The square y over the s square, and this is what? M square e raised to power ms. Do you understand? Substitute into this equation. The square y over the s square is what? M square e raised to power ms. You put it here. M square e raised to power ms plus 8. The y ds is what? M e raised to power ms plus 16. Y is what? Y is e raised to power ms. E raised to power ms is equal to 0. Divide through by ms, e raised to power ms. When you divide through by e raised to power ms, you have m square plus 8m plus 16 equal to 0. So this m square plus 8m plus 16 equal to 0 is what we call the auxiliary equation. So you solve, this is the auxiliary equation. You solve this, you have what? M plus 4 raised to power 2 equals 0. So m equal minus 4 twice. Do you understand? So this one, the two answers you get is minus 4. They are the same. So what will be your solution? Your solution will be what? Y equal, don't forget you said y to be e raised to power ms. So it will be equal to e raised to power, the first answer minus 4x, right? Plus the second answer e raised to power minus 4x, but they are the same. So one of them you have to have what? S, then put constant c1, c2. That's what we are talking about. When you have the same answer, one of them you have x. So y will now be equal to c1 e raised to power minus 4x. You can factorize e raised to power minus 4x to have c1 plus c2s e raised to power minus 4x. Do you understand? So that is the answer. So now let's come to the third one. So after the third one, the fourth one, after the fourth one, the fifth one, and we are through. So now the third one, number 3, you have this square minus 9y equals 0. So what is this square? This is another way of writing the differential equation. This one means they have differentiated the second time. This is another way of writing it. This actually means, if I open the bracket, this is the square y minus 9y equals 0. This is the square y means the square y over the s square. This capital D. This capital D is representing, if they write the n, it means the n over the sn. That's what it means. So if you put y there, it means the ny over the sn. So this square y now means that if you say d square y, it means this square only is this square over the s square. So if you now put y, it's the square y over what? The s square. Do you understand? So this is the square y over the s square. So let me write it well for you so that you will see it. This is the square y over the s square minus 9y. So let what? Y be equal to e raised to power mx. Differentiate the first time and the second time. If you differentiate y prime, this is m e raised to power ms. Differentiate the second time, y prime prime equal m square e raised to power ms. So mind you, y prime is another way of writing the y ds. Y prime prime is another way of writing the square y over the s square. So put it here. The square y over the s square is what? M square e raised to power x. So this is m square e raised to power mx minus 9y. Y is e raised to power mx. Do you understand? Equals 0. Divide through by e raised to power mx. You'll be left with what? M square minus 9 equals 0. And what do you have? Plus or minus 3, isn't it? M square minus 9 equals 0. So m equal what? Plus or minus 3. Just do m plus 3, m minus 3. Difference of 2 square. Because this one is 3 square, m minus 3, m plus 3. And this will be your answer. M equal plus or minus 3. So they are different answers. M1 is 3, M2 is minus 3. So y will just be equal to C1, the first answer, e raised to power 3s plus C2 e raised to power what? Minus 3s. And that's what, that's the answer to this third one. Now, the fourth one, The fourth one, the same thing. The fourth one is what? D squared plus 3d minus 1y equals 0. So this is d squared y plus 3dy minus y equals 0. So again, let me show you. Let y be equal to e raised to power mx. So the auxiliary equation will be what? So what will be the auxiliary equation? So you will just put, you will differentiate y the first time, differentiate y the second time, and put there. So the auxiliary, even without me differentiating and putting it there and dividing through by e raised to power x, that is what you should do. What will be the auxiliary equation? The one, this is d square, this one will be m square. If you see, all the d square we have been doing, at the end of the day, they become m square. So this plus what? Plus 3 dy, this is the y there, plus 3m minus what? 1 equal 0. That's what it will be actually. That is what your auxiliary equation will be. So you can confirm it, differentiate the first time, differentiate the second time, put it inside the differential equation and divide through by e raised to power mx. Your auxiliary equation will be this. Then you solve this quadratic equation. This is actually, you have to use formula method here. If you solve this one is minus 3 plus or minus square root of what? Minus 3 squared, that's 9 minus 4. A is 1, C is minus 1, all over 2a, 2. I'm using formula method to solve the quadratic equation. So m equal minus 3 plus or minus square root of what? 9 plus 4. All over 2. So what do I have at the end of the day? 9 plus 4 is 13. M equal minus 3 plus or minus what? Plus or minus. So actually I want to do something. I want to make this one plus so that you will see an example on this third part. Okay, even if I make it plus, it doesn't change anything. So let's leave it as minus. So this is square root of 13 over 2. So you can get it if you can use calculator to solve, or this one will now be minus 3 plus root of 13 divided by 2. The answer is what? 0.3028. And the second one, minus 3 minus root of 13. Minus 3 minus root of 13 over 2. The answer is minus 3.3028. That is what you are going to have. So actually there are two different answers. So the answer to this one will now be y equal c1 e raised to power what? 0.3028x plus c2 e raised to power minus 3.3028x. That is what the answer will be. Now, before I solve the last one, or let me solve the last one. No, before I solve the last one, let's solve this one. Y prime prime plus 5y prime minus 10 is equal to minus 10y equal to 0. So you will let y to be equal to e raised to power ms. You know that already. So y prime, let me just do y prime, m e raised to power mx, y prime prime m square e raised to power mx. So put it there. So this is m square e raised to power mx plus 5m e raised to power mx minus 10 e raised to power mx equal 0. So divide through by e raised to power ms, you will get the auxiliary equation. Look at it. You will have what? M square plus 5m minus 10 equals 0. So even without me going through all this way, I'll just let y equal e raised to power mx. I'll just write auxiliary equation will be this y prime prime will be m square plus 5 y prime will be m minus what? 10 equals 0. Do you understand what I'm trying to say now? So solving this, m will be equal to what? Minus 5 plus or minus square root of what? Minus 5 square minus 4. No, let this one be plus. So please let this one be plus. So if this one is plus, so minus 4, a is 1, c is 10, all over what? 2a. So this is minus 5 plus or minus square root of minus 5 square is 25. 25 minus 40 all over 2. 25 minus 40 is what? Minus 15. So 25 minus 40 is minus, so m is equal to what? Minus 5 plus or minus square root of minus 15 all over 2, right? So now separate it. So that means this is minus 5 over 2 plus or minus this. You know that whenever you have square root of minus 1, it is I from 001, like it is I from complex number. So this is plus or minus square root of 15 I, because square root of 15 is what? Square root of 15 is what? Minus 15 rather is square root of 15 times square root of minus 1. What is square root of minus 1? I. So this is the square root of 15 I. Do you understand what I'm saying now? So that is what we have. That's what we have. So all over 2. Minus 5 over 2 plus or minus square root of this one. So if you look at it, it has conformed to this one I'm talking about, m equal a plus or minus bi. So in this case, actually, your a is what? Minus 5 over 2. And your b is what? Root 15 over 2. So the solution to this equation, for this one, whenever you have a complex answer, the solution will be what? Y is equal to what? E raised to power first, e raised to power as. That is e raised to power minus 5 over 2s. Open a bracket, then c1 cos. What will be in this bracket is c1 and c2, then cos and sine. Cos b is 15 root 2 s plus c2 sine what? bs root 15 over 2s. That's the answer to that question. Do you understand? So whenever you have this, now lastly, number 6, we have y prime prime minus 3y prime prime minus y prime plus 3y equal to 0. What do? It's now fun. Let y be equal to e raised to power mx. What will be the auxiliary equation? Don't waste time. This, you see, y prime prime 3 times. This one will be m cube. You can check. That means you will have to differentiate till the third one and put it there. This is one will be m cube minus 3m squared minus m plus 3 equals 0. Do you understand? M cube minus 3m squared minus m plus 3 equals 0. If you don't believe or you don't understand, solve it out. Do y prime prime, y prime prime. Like differentiate the first time, differentiate the second time, differentiate the third time, and put it inside this. You will and divide through by e raised to power ms, and you will get this answer. Now m squared is common here. M squared is common here. What will remain? M minus 3. Isn't it? Minus 1 is common here. Minus 1 is common. You are left with m minus 3. So that means this one will be what? M minus 3. Then you have what? M squared minus 1 equal to 0. Actually, this is a third order differential equation because we differentiated 3 times. Now, what do you have? M minus 1, M minus 3. Now, this is difference of 2 square. M squared minus 1 is difference of 2 square. You have M minus 1, m plus 1 equal to 0. So you will get 3 answer. Of course, it's a cube. So m equal 3. You have 1. You have 1 and minus 1. So when you get 3 answer like that, what will be the solution? What will be the solution? The solution will be y equal c1. Of course, you always put constant. E raised to power 3x plus c2 e raised to power what? 1s, which is same thing as s. Then plus c3 e raised to power what? Minus 1s, which is minus s. Please kindly subscribe to this YouTube channel. Thank you very much. I am Adedoyin Jeremiah.